I hope you're all enjoying the conference. Good. I have been pulled back into my work too much, hoping to do a bit more with the sessions. So thanks for coming to our session today. My name's Joe Murray, and with me is Luke Yang. We're going to be looking at transparent data encryption using Percona MySQL and HashiCorp Vault. JMA is a small company. We do consulting for nonprofits, and we have staff in Australia, in India, and Canada. And Luke is an engineering student at the University of Toronto, probably the best engineering program in Canada, engineering science. And he's just starting a job for the next 16 months with Red Hat, working on Fedora. So this is his work last summer, and it's in use, and we're very happy with it. So here's an overview of our talk. I'm not going to read through all the points here. Basically, I'm going to start by giving an overview of the problem and what our minimum viable product was. And then most of the talk is going to be Luke going over all the details of our implementation. I guess the thing that's special about this is it's free all the way through, and it's TDE. And so I don't think there are other options for doing something yourself that doesn't involve paying a subscription fee or anything and getting MySQL TDE. So that's what you're going to get today. Okay. So what's the context? We're this year going to be launching a new software as a service based on Civi CRM and WordPress. And a little bit of background about us. We're Civi CRM experts, and we host nonprofit websites, and there are millions of contacts in our databases. So Civi CRM is an open source project that started in 2005. It's designed for nonprofits from the ground up, does things like donations, memberships, event registrations, case management, volunteer management. It's kind of like ERP for a nonprofit. There's maybe 5 or 6 dozen consulting shops in the ecosystem, and hundreds of developers contribute code every year. We're kind of in the top tier. 2 of the top 5 contributors to the core code work for JMA. So a little bit more about Civi CRM. It works with the open source CMSs that are popular: WordPress, Drupal, Joomla, also a fork of Drupal. So it requires some version of MySQL, any flavor. And the nonprofit clients tend to be very cost conscious, which is part of what drove us here to looking for this solution. So how did we get involved with software as a service? We worked with an organization that does a donor portal in Canada. They process maybe almost $500 million in donations. It's over a quarter of the online donations. And they came to us because they were looking to provide the charities with a CRM system. So we heavily customized Civi CRM and Drupal for them, and enhanced an existing bulk hosting system for Drupal and Civi, and so that it could onboard things, talk to Google to get a new subdomain set up, talking to email systems, setting up all sorts of stuff. So they are onboarding a couple dozen new charities every month. They're getting a couple million in revenue from our work, and we're thinking, interesting. Then last year we worked with another organization on a 6-figure contract, which is big for our tiny company. The OBIA is Ontario Business Area Improvement Association, and so they represent main streets across the province of Ontario. And they wanted a SaaS that they could market to all of their little towns, BIAs. And so with that, we leveraged our experience from 2021 to put it with WordPress and Civi CRM. WordPress is easier to administer. So we developed this product, and we're using it with OBIA, and then we're aiming to launch our own SaaS this year, and we'll probably do some others that are more targeted to particular verticals like choirs or counseling centers. So we needed something that could host health data and lower the risks of data loss from hosting. We have several million in insurance, but it costs about $180 for every contact if you have a data breach in order to provide them with all the services they would require. And when we're hosting millions, it would bankrupt us. So we have some insurance, but not enough. So TDE, what is it? It's encryption of data at rest. This is probably old hat for most of you. MySQL provides options for tables, logs, bin log as well when it's going across from primary to secondary. Also the backups. We needed to have encryption of the backups. And it can be implemented in MySQL for various layers: cluster, database, table, or column. Table and column are a little bit more for, you need changes in the application code, and it's good if you're trying to have encryption in use. TDE supplements other kinds of encryption. So disk level encryption is good for protecting against physical loss of your drives, and data in transit encryption for all sorts of things that I list there. So it's only one part of defense in depth against data loss. So why did we choose database TDE? There's no way we're ever going to refactor WordPress or CiviCRM. CiviCRM has over 1 million lines of code. It's 17 years old. It's a very mature product. We wanted to be in compliance with HIPAA, so TDE would enable that, and other standards. We don't have to worry about PCI DSS ourselves because we don't store card data, but there are other standards we wanted. The big one was lowering data loss risk, and it is available from some of the big hosting companies, but we're trying to hit a lower cost market. And so the project was aiming to have the simplest high availability design for MySQL database TDE. We're going to do other things on top of it, like load balancing for the web server level, but this was focused on the database. So what were the options we were looking at? MySQL Oracle, it doesn't provide a free version. It comes with the Enterprise Edition. MariaDB, we were thinking we were going to be able to use them. We didn't like file key management because it doesn't allow for key rotation. And if your key gets compromised, you're in trouble. It does support AWS, but we didn't want to pay. And Apiri was an old system for key management, but by the time we were looking at it last summer, Apiri was no longer offering it. So that was their only option for us, and it was gone. With Percona, they again have file key management, which we don't like. And we were happy to see integration with HashiCorp Vault. We got on the phone with them to find out how much the Enterprise Edition was. It's 5 figures or 6 figures per year, kind of out of our range. But they did have a community edition, and the only restriction there was you could only use it in one data center. You couldn't do it across data centers. And for our purposes, that's acceptable. So that's the context. And now I'm going to pass it over to Luke. Yep, any questions?
Go back. Could you clarify the file load key rotation? Because there's literally a command that says alter rotate master key. I'm just trying to understand why do you say no key rotation? There's literally a command that does key rotation.
So that's a good question, and I might be wrong. When I looked at the Percona documentation, they said that they couldn't support it. So this was Percona's documentation, and so my other concern was around the safety of having the keys available and having to manage it ourselves. But I can provide you after the exact line in the documentation, because I was just looking at it this morning.
I think that here as well, like all the keys are started on the files. If you compromise, if your file gets compromised, you have all the keys. For the green file. So even though you rotate, which is what they're going to do, for the key, you have to compromise it. If you want to get access to the file,
And so in terms of what we're trying to protect here, it's protecting the data on the server when it's there. And so it's for, if there's someone has already gained access to your server, you don't want them looking at things on disk. And so I was concerned about, if they're able to get into the server, escalate to privilege of root, then they might be able to do something with the keys. So that was why. And then there was also this documentation saying it wasn't supported in terms of rotating. I think that if you export your database, then you can do key rotation. You need to load it up again or something like that. So it wasn't able to handle it while in use. But I'll get you the thing.
Yeah, so in our diagram, there's a lot of components going on here, but we will draw your attention to the fact that there are three distinct layers. And so in the first layer, we have an Apache web server, which will provide a front-end site probably built upon either WordPress, Drupal. We integrate with Civi CRM. And then each of these sites needs to be connected to a database, which is what leads to our second layer, which has two Percona MySQL instances, both with GTID replication enabled and TDE configured. So what happens is the front-end web server will send data to the primary Percona, and then the secondary will just replicate any changes that occurred to the first. And then finally, we need a place to both store and retrieve the encryption key used by Percona TDE, which leads to our final layer, which is 3 HashiCorp Vault instances arranged in a high availability cluster. And so what happens is the primary Percona accesses the active vaults for its keyring. And then what happens is then the standby servers will just replicate any changes that occur on the first. And yeah, overall, that's just kind of the relationship between the web server, the database, and the key management system. But you may be wondering, oh, we have like backup servers and over here and over here. What happens when the active one goes down? And how do we minimize downtime and that a site can still keep running? And that leads to some additional software, which is, oops, my bad. ProxySQL, Orchestrator, and HAProxy. And so starting with ProxySQL and Orchestrator, Orchestrator is used to both monitor and manage the topology of the replication relationship between the two Percona servers. And so in other words, it can detect which one is the active server, and then also if the primary goes down, it'll automatically promote the primary as the new active, which is good for failover. On the other hand, ProxySQL is a MySQL protocol proxy that will accept traffic from the front-end web server and then redirect it to whichever it detects as the active Percona server. And so with these two, you can establish a failover for this layer. Similarly, HAProxy is a load balancer used to accept traffic from the primary Percona, and then it will redirect it to the 3 Vault servers in a round-robin format. And we use a round-robin because if you happen to send data to one of the standby vaults, it will be automatically redirected to the active server through its API. And so basically, that just makes our lives a lot easier because we don't have to figure out which one is the active and just like send data to all 3. But yeah. Sorry. Finally, we implement SSL or TLS for end-to-end data encryption. And we use Let's Encrypt certbot, which will generate a certificate and key for TLS and then also automatically renew it because they do expire every 90 days. And while it seems pretty straightforward to implement, this was actually quite challenging, primarily due to the fact that each of these individual software has its own process and requirements for enabling TLS and SSL. And additionally, we needed to figure out a way in order to reload these certificate and keys that have renewed without having to stop and start the service. And that itself incurs some downtime. The specifics of how we did that will be briefly touched upon as we go on with our talk. But You can always refer to the documentation that we have for all of this, which is pretty thoroughly documented. Go to the JMA Consulting GitHub and look for CiviPress. And yeah, so as a final point, you may notice that each of these components are on a different VPS or virtual machine, and that just makes sure if one part goes down, it has a minimal impact on the whole service. It's kind of the backbone for high availability. And as a second point, we also notice that no two VPS on the same layers on the same physical server. And so that's for the case of when an entire server goes down. And just one final point, for production, for development, we've only been able to implement a single front-end instance, but in the future, we would like to implement high availability for that as well, but that's a work in progress. Yeah. So that about covers the overview, but we will be going to the specific components now, starting with the HashiCorp Vault cluster. The first thing is we assume you have a VM or VPS set up with some Linux server. And after that, the first step is to install Apache and Let's Encrypt certbot. We won't actually be using Apache to serve anything, but it is needed by certbot in order to renew its certificate and key. And so once that's configured, we then proceed to install HashiCorp Vault Community Edition, and then create its configuration file. And that has important information, such as the IP address and port for API communication, specifying the TLS certificate and key generated by certbot, as well as the data storage location. As a side point about data storage, we've opted to use HashiCorp Vault's integrated storage feature called Raft Storage. And HashiCorp Vault does support remote data storage, such as console, but we've decided to use Raft because it keeps everything on the Vault server, reduces like the total number of servers we need and just the complexity of our service, but that is an option. Yeah, moving on. Once everything is configured, you can now start the Vault server, which will give you 5 key shares and a root access token. And you use these to first unseal the Vault and then log in as the root user. We won't go into the specifics of why and how Vault does this, but you can always refer to the official HashiCorp Vault documentation if you want a more in-depth understanding. And yeah, as you are the root user, you can now enable KV Secrets Engine, which creates an API endpoint to allow Percona to access HashiCorp Vault so it can store and retrieve its encryption key needed for TDE. Yeah, with that, you should have an instance of HashiCorp Vault up and running. But however, you will need to repeat steps 1 to 3 for your 2 standby vaults onto different VMs or VPSs. An important difference, though, is actually the way you start the vault. It's different than how you start the first one. You actually need to specify the API address of the first one, and that adds it to the cluster. And after that, you have to unseal it with the same key shares that you were given in the first one. Yeah, that's setting up all 3. Finally, to automatically reload Vault with the renewed SSL certificates and keys, we create a bash script, and that has a simple HashiCorp Vault command that will reload the certificate and key without having to stop and start it. And what we do with this script is we put it in the Let's Encrypt certbot's hooks folder. And so if you put it in that folder, it will just trigger whatever script is in there whenever a new certificate and key is renewed. And yeah, we just stick it in there. Everything's automatic. All great. So yeah. Of course, detailed steps found in our documentation. Refer to the documentation. And as a side note, we've decided to use a cluster of 3 HashiCorp Vaults instances, but you can scale that to however large you need to fit your design requirements. Yeah, with the Vault cluster up and running, it's now time to configure TDE and GTID replication on Percona MySQL. The process is exactly the same as before at the start. We have to install certbot and Apache on both the Percona servers. We then proceed to install Percona MySQL and edit its configuration file. And some things you have to specify are the SSL certificate and key, enabling the Keyring Vault plugin, enabling GTID replication, and starting the servers in read-only mode, which is a requirement for GTID replication. Basically, the Keyring Vault plugin allows Percona to interface with HashiCorp Vaults API using the endpoint that we created previously using the KV secrets engine. So the plugin also has a configuration file where you'll specify the API endpoint, TLS certificate, and a Vault access token, which is what gives its permission to access Vault. We can also configure automatic encryption key rotation by using a bash script and cron job to execute the MySQL command to rotate it on a scheduled time interval. With that, TDE with Percona set up. For GTID replication, we actually need to create a new MySQL user on the primary Percona that will allow the secondary to gain access and perform replication. As an important note, we create two users, one giving access from the secondary server and one giving access from the primary. And while it seems weird that we're giving the primary access to itself, we do this for when the case failover occurs and the secondary is the new primary. And so we still need access to it. And so that's why we make that user as well. Moving on. Go to the secondary server now. Hope you're still following. It's a little bit confusing, but you specify the primary server as the master you're replicating from. At this point, you can enable SSL between the servers at this point as well. Start the replication. GTID should be configured. And then last step, you disable the read-only mode on the primary and then connect it to a front-end site as usual. Now, to automatically renew the SSL certificates and keys, the process is arguably a little bit more complicated than for Vault, but the overall process is the same, which is make a bash script with a MySQL command to reload it without having to stop and start it, and then stick it into the Let's Encrypt hooks folder. So I note, once again, we have a primary-secondary replication relationship, but you can probably add more replicas depending on whatever design requirements you need. Now, before moving on to talking about HAProxy, there was one more software that we didn't talk about in the structural overview, which is Vault Agent. The reason why we didn't talk about it is because it pertains to a very specific concern relating HashiCorp Vault and its access tokens, which previously stated you need that access token for the Keyring Vault plugin to gain permission to access HashiCorp Vaults. And the main thing is that these tokens expire. And while you can technically set a really long expiration period, obviously not a great thing for security because the expiration is what limits the damage that a compromised token can do. But on the other hand, it's also pretty impractical to manually renew these every single time that the expiration date approaches. And it's important that we do renew them because if you use an expired token, Percona will just not have access to Vault anymore. And that can't decrypt and encrypt the data, and that just leads to unwanted downtime if you don't account for it. So how do we solve this? We've decided to use HashiCorp Vault's app role authentication feature, which basically it allows an authenticated user to generate a new token on command. And an important security feature of app role is you can restrict which IP addresses you can generate the tokens from. So for example, in our case, we restrict the IP addresses to our 2 Percona servers, and you can only generate tokens if the request is coming from either of those 2 IPs. on the Vault, primary Vault server, you'll need to enable the app role and proceed to create a new authenticated user with these requirements. And then that's all configured. Move on to the Percona servers, install Vault and configure Vault agent. And then what we do is we create another bash script that will trigger Vault agent to generate a new token and then loads it into the Keyring Vault plugin configuration file. And then we uninstall, then reinstall the plugin, which will basically reload its token, but we don't have to stop and start Percona. Once again, refer to the documentation. So, yes, yeah.
Have you opened a feature request with Percona to just have a command of reload token instead of having to uninstall the plugin and install it back in?
Oh, no, I haven't. So wait, is that implemented or not?
No, I'm saying you should open a feature.
Oh.
It's very simple to do.
Oh, cool.
Open a feature. It's our plugin, so you should open a
Sounds
feature
great.
request and say, can we get this one? You're not the first person who's come across this problem.
Oh, interesting.
So I'm on the forums for Percona very frequently.
Yeah.
And people have asked about the same problem. How do I rotate the access token?
Yeah.
And basically that's the same answer. So you're now at least the second customer that I know of that needs this.
Okay, yeah.
Open a feature request and say, we would like a rotate token, reload token, stuff so you don't have to do all those reloads.
Sure, yeah.
Thanks. Just to respond to your earlier question, I found the documentation for MariaDB. Your documentation has changed a lot in the last 12 months, and I can't find it yet, so you might have implemented something. So thanks a lot. We're going to try and help Luke by not taking questions until the end.
Yeah. That was awesome, though. Thank you for that. Yeah. Where was I? Yes, okay. With Percona and HashiCorp Vault finally established, we now move on to configuring HAProxy to allow for Vault failover. So on each of the Percona servers, you'll need to install HAProxy, edit its configuration file, and then you specify things such as the Percona server where it's receiving traffic from, and the 3 Vault servers where you're sending data in a round-robin format. And at this point, you can also enable SSL when both receiving data from Percona and then sending it out to the Vault servers. And in the case that one of the Vaults is down, it will just send the request to the next available Vault server in the round-robin format. And so everything will keep running, no downtime, hopefully, but yeah. To automatically reload HAProxy with the renewed SSL certificates and keys, same process. Bash script, put it into the hooks folder. One key difference, though, is you do need to install SOCAT, which is used to send an API request to HAProxy, which will let it reload its token, reload the SSL certificate and key without having to stop and start it. But yeah. Okay, we move on to our final components, which are ProxySQL and Orchestrator. Once again, install Apache, let's encrypt certbot. You'll then need to install an instance of Percona MySQL local instance on the server, since Orchestrator does need a backend to operate. And then we proceed to install ProxySQL and specify the primary and secondary Percona servers. ProxySQL also needs a MySQL user that is able to monitor the status of each Percona server. And so create that on the primary, populate it in the ProxySQL configuration file. And then at this point, make sure to enable SSL on both the front-end connections and the back-end connections. Now on to Orchestrator. First, install it, and then as previously stated, it needs a backend. So on the local Percona instance, create an Orchestrator database and user, and then populate the configuration file. And then, Orchestrator, basic operations all set up. We then proceed to create a new user on the primary Percona server, which will allow Orchestrator to both monitor and control the relationship between the 2 Percona servers. And then, edit the configuration file, specify these credentials, specify the SSL certificate and key, and then enable the automatic failover. And that will just do everything automatically if one thing goes down. As before, use a bash script, let's encrypt hook, reload SSL. Don't have to stop and start either. All can be found in our documentation. So hopefully you have a general understanding of how to implement a service similar to ours. And you're free to do so. I hope that you can look at our documentation. It'll give you more insight of how to do this. But we do want you to do so if you really want to. However, as a side note, we've also created a set of Ansible scripts to automate most of the process from start to finish. A point is that there is no formal documentation for the script, but if you do refer to the manual documentation that I've been plugging throughout this whole talk, it basically follows it step by step. But the thing is, the scripts run in a way that it's catered towards how we've set up our VPSs. So for example, there might be a password stored on a file, and then we cat it in the Ansible script so we can create a new user. You probably may or may not have that set up, but if you understand the manual documentation, these changes are pretty simple for you to figure out, I would hope. And yeah, from my personal experience as someone very familiar with the software and this service and how to implement it, if I were to do it manually, it'll probably take me an entire workday's worth of time, which is around 8 hours. With these scripts, I've been able to cut it down to 1 to 2 hours, which is pretty good, I think. So, yeah. Just a few operational considerations. Currently, it requires 2 people to unseal the vault. By default, it's 3, but we've decided to do.
We're a small team,
yeah.
And we wanted to make it possible for us to have it 24/7, and so that's why it's down to 2.
Yeah. Another thing, implemented practice failovers, vault cluster healing, and database restores. Just make sure everything is running smoothly, and yeah, covers all our bases. And then finally, as a final note, we've been in production without incidents since September 2022. That's a good thing. So hopefully we keep going strong. Yeah. So as we conclude, we come to challenges and lessons learned. There are many, many challenges along the way. And primarily due to the fact that we're a small team, but pretty much all of this was a first for us, and so that ends up bringing a lot of trouble in. But first, there were a lot of documentation for the individual components, and the thing is, there didn't seem to be explicit instructions or documentations for exactly how we want to put our service, and so that ended up creating a lot of points of research for us, trial and error. And a big thing is reaching out to the community, such as the forums on Percona and HashiCorp Vault. We've asked lots of questions. We've also gotten lots of great answers that have helped us a lot along the way. But yeah, that was one thing. Second, figuring out the unique ways in which each software enables SSL and was just pretty difficult, primarily due to the fact that there could be so many factors contributing to why a connection wasn't occurring. Yeah, also in some cases, documentation or tutorials didn't include how to implement SSL, arguably for the sake of simplicity because it is a tutorial, but nonetheless, it is an important thing that we had to implement and figure out. Finally, trying to solve the issue of reloading, for example, Vault access tokens and SSL certificates and keys without needing to restart the various softwares was somewhat a niche problem. We did have to do a lot of digging to figure out how to implement this, but certain things such as introducing Vault app role, Let's Encrypt hooks, bash scripts, and cron jobs were a solution we took into our own hands to try and address this issue. But yeah, overall, from the challenges we faced, we've definitely learned a lot of things. Number one big thing, reach out to the open source community. There's a lot of great dudes out there that want to help you out, and we've personally experienced that, and we're very thankful for that. And as a second point, as for any engineering design process, you have to embrace the iterative nature of engineering design. And that's because you will, without fail, come across unexpected problems you did not plan for in the original plan. But overall, I think I had a great experience implementing this, and I think it was a fun project. So on to you, Joe.
So thank you very much. We're trying to give back after getting from the community, helping others by documenting a whole bunch of the unexpected core, problems that are required in order to put something into production. So we're making this all available through documentation in these Ansible scripts. We tried to have this quick in case there were questions, and we're open to comments. We'll certainly, we work in open source, and we are senior players in our little thing. Trying to deal with MySQL or Percona is like this great big thing. And so putting in a feature request didn't even occur to us. Thank you for that. Yeah. The other thing is I did, I don't know, 10 or 15 years ago, put in a bug report on MySQL on a particular type of query and everything. They get lost. It's a big community, but it is good to document. And so we did produce a bunch of forum posts and clarified both with HashiCorp Vault, and I don't know if you were the person, but different people at Percona helped us out. So thanks for that.
Do you happen to be Matthew by chance? I do remember receiving your wonderful messages, and I could just see of me typing a stupid question, and you're like, "No, that's not how you do it." I'm like, "Oh dear." But
he would come and consult with me or the technical lead. As we posted back to you.
But so great to see you in person. Thank you for all that you've done for us. So yeah.
Any comments? I know. I was on a different project trying to figure out how to do encryption for Postgres, and currently I couldn't find any that would do TDE without paying, and even when you did pay, it's generally this manual file with key rotation issues. So we're looking to, Decidim had one, and sorry, not Decidim, that's the software we're trying to use it for. The one that we liked is from Enterprise DB, which you referred me to yesterday, but it's going to be a paid subscription. Yep. No, I'd love it. There's a small number here. We wanted to use CertBot to automatically renew our certificates. So that was our big goal. And we haven't gone into any particular configuration that I recall.
Yeah.
It's just we needed encryption of data in transit all the way through the data center, and so that's why we did this.
Yeah.
We're trying to.
Yeah.
We're little people trying to grow up into a more mature product and security environment. Yeah. So this is our effort to go. Most of the hosting for WordPress or Drupal and Civi CRM, it's all just the web server and the database on a single server and no encryption, and that's pervasive. There are some that are hosting in AWS, and when you can just turn it on, then they're using it. But we were trying to make use of fully FLOSS oriented approach. Well, thank you very much for your time today. And thank you, Matthew.